Imagine you're pitching in 10-foot swells, right? You're like 500 miles offshore. Salt water is just absolutely blasting the deck. The wind is howling against the hull.
Sounds pretty terrifying, honestly.
Right. But then picture the owner of this vessel. They're sitting completely comfortably inside the cabin, flawlessly streaming a live 4K video presentation to a boardroom in Tokyo.
Which is just wild to even think about.
It really is. I mean, it used to be that taking a vessel out into the harsh, unpredictable ocean meant, above all else, cutting yourself off from the world. You know, you cast off the lines and you were just untethered.
Yeah, you were completely on your own out there.
Exactly. But today, if you step onto a modern luxury vessel, that isolation is entirely gone. Taking a yacht to sea now requires navigating the physical ocean while simultaneously operating this floating, highly complex, enterprise-grade digital ecosystem.
It is a massive paradigm shift in maritime engineering. I mean, we've gone from vessels that were essentially, beautiful mechanical islands to vessels that are fully integrated nodes in a global communications network.
And it's not like the ocean got any nicer.
No, not at all. The environment they operate in hasn't gotten any gentler.
Yeah.
So the challenge isn't just installing the technology, it's making server room level hardware survive literally the most corrosive, violent environment on Earth.
And that tension between cutting-edge digital integration and the brute force of the ocean is exactly what we are exploring for you today in this deep dive.
Yes, it's a fascinating topic.
We are pulling our source material today from Concord Marine Electronics. They're a premier marine technology firm based right in the heart of the yachting world, over in Fort Lauderdale at the Safe Harbor Lauderdale Marine Center.
Right.
So our mission today is to explore the true anatomy of modern yacht electronics. We're going to unpack everything from the absolute essentials of navigation to some truly wild high-speed internet blending technology.
And I think more importantly, we're going to look at the underlying architecture because, we need to understand why having all the most expensive top-tier gadgets bolted onto a boat means absolutely nothing if they aren't properly integrated into a singular nervous system.
Totally. We're going to reveal why a simple split-second Wi-Fi drop could completely ruin a luxury charter experience, and how marine engineers managed to take a vibrating salt-sprayed vessel and basically turn it into a flawless smart home.
It's basically magic. But practical magic.
Right. But before a yacht can become that floating luxury resort, it fundamentally has to operate as a safe, navigable vessel. So the foundation of this entire electronic ecosystem has to start right at the helm.
Yeah, and the modern helm is a very long way from a wooden wheel and a compass. The baseline now is what's called a multifunction display, or MFD.
Those are the big screens, right?
Exactly. They are these massive glowing screens you see on modern bridges, and they serve as the central command center. I mean, they are doing an incredible amount of heavy lifting.
What are they actually displaying?
Well, they're combining your digital charts, your AIS, which is the automatic identification system used to identify nearby commercial and recreational vessels, your sonar, and your autopilot. And it puts all of that into one single, seamless interface.
And the Concord sources break down how different brand ecosystems actually cater to very different profiles of how a yacht is used, which is interesting because you don't just buy, screens, you are buying into an operational philosophy.
Yeah, that's a great way to put it.
For instance, if you look at Garmin, they are known for having incredibly intuitive chart plotters. It's designed to be a very owner-friendly helm setup, highly visual, super easy to navigate.
Very user-friendly.
But then you have Raymarine, which is highly regarded for its deep, robust integration between the navigation software and the physical autopilot systems. And then if you look at Furuno, they are the heavy hitters for advanced radar and serious, rugged offshore navigation.
Yeah, Furuno is legendary for that stuff.
Okay, let's unpack this for a second. If I am out on the water, my GPS tells me my exact coordinates, right? That's basically Google Maps for the ocean.
Sure.
So why is radar still considered an absolute non-negotiable priority by these engineers, rather than just some optional luxury upgrade? Isn't knowing exactly where I am on a digital map and maybe seeing the AIS signals of big ships enough to get by?
What's fascinating here is the critical distinction between knowing your position and knowing your environment. To build on your analogy, Google Maps is fantastic, but it relies on the assumption that the roads are static and, generally empty.
Right. And the ocean is definitely not a static road.
Exactly. The ocean is never static, and it is rarely empty. GPS tells you precisely where you are, but radar tells you what is physically happening around you in real time, regardless of whether that object is broadcasting a signal.
So it's basically filling in the massive blind spots that a digital map simply cannot account for.
Precisely. Radar is essentially the yacht's live headlights. I mean, imagine driving down a highway at pitch black night, but instead of headlights, you only have a GPS screen telling you where your car is on a digital map.
Oh, wow. That sounds like a disaster waiting to happen.
It is. You wouldn't see the deer running into the road or the car stalled in your lane. So out on the water, radar is what lets you see in the dark. It actively bounces radio waves off physical objects to paint a picture of your surroundings.
So it can see through weather, too.
Oh, absolutely. It cuts through fog, heavy rain, zero visibility conditions. It tracks severe storms as they develop on the horizon. But most importantly, it shows you the unlit wooden channel marker or the small fiberglass fishing skiff that isn't broadcasting an AIS signal.
Right, because not everyone has a transponder.
Exactly. So for collision avoidance and busy waterway navigation, radar isn't a luxury. It is the fundamental tool that keeps you alive.
That drastically changes the framing. You aren't just plotting a static course. You are continuously scanning a dynamic, hostile environment.
Yes, constantly.
But, okay, once you have that immediate physical perimeter secured by the radar and the MFDs, the scope of what the yacht needs to connect to expands drastically, which brings us to the digital lifeline yacht internet.
Oh, yeah. And we really have to be clear about the scale here. This is not just about, sending a quick text message to say you arrived safely at the marina.
All right.
The operational and luxury expectations have just completely skyrocketed.
They really have. I mean, the Concord materials emphasize that yacht internet now has to support a staggering enterprise-level data load.
It's massive.
You've got the owner doing high-definition video conferencing with their office. You have guests scattered across multiple decks, streaming movies in 4K. The crew is communicating and managing logistics.
And don't forget the boat itself.
Right. The vessel itself is constantly pulling down massive weather and navigation updates, running remote engine diagnostics, and pushing telemetry data to cloud monitoring systems.
To meet that demand, the industry has seen a total revolution with low Earth orbit satellite networks. Specifically, we're talking about hardware like Starlink Maritime Gen 2 and Gen 3.
Starlink has completely changed the game, hasn't it?
Oh, fundamentally. It provides latency and bandwidth offshore that honestly rival fiber optic connections on land.
But here is a massive point the sources make. Even with the raw power of Starlink, a single source of internet is never enough for a modern yacht.
Nope, never.
And this introduces a piece of technology I found wild, the MDS Blender. It's this specialized marine network router. The documentation explains that it bonds up to 4 different internet sources together.
It's an incredible piece of hardware.
We're talking about taking Starlink, LTE, or 5G cellular networks and Marina Wi-Fi and literally mashing them together to achieve speeds of up to 1 gigabit per second.
Yeah.
It features programmable bandwidth allocation and what they call true instant failover. But I have to push back on this a little, though.
Okay, let's hear it.
If Starlink is so incredibly fast and revolutionary, adding a 5G connection or a potentially spotty Marina Wi-Fi network as a backup just seems like, well, massive overkill.
I can see why you'd think that.
It feels like buying a Ferrari and then keeping a bicycle in the trunk just in case the engine sputters. Why overcomplicate the network architecture to that degree?
It's a fair challenge, but if we look at how these vessels actually operate, the Ferrari analogy doesn't quite hold up. Because the goal of the MDS Blender isn't just about hitting a peak speed number on a speed test.
Okay, so what is the real goal?
The true goal is absolute, unbroken consistency. Look, if you've ever been frustrated by your home Wi-Fi dropping because you walked into the kitchen, imagine trying to maintain that signal while your entire house is bouncing over waves at 30 miles an hour, far away from any cell towers.
Right, that sounds impossible. So the priority is shielding the user from the physical reality of the ocean's interference.
Precisely. Let's go back to that owner on the super yacht. They are on a crucial, multi-million-dollar remote desktop session or giving a live presentation to a board of directors.
It's high-stakes stuff.
Exactly. If the vessel pitches hard in a wave or passes under a massive bridge, the satellite dish might lose its line of sight to the sky for a fraction of a second.
And if you only have one connection.
If you only have a single-source internet connection, that connection drops. The video freezes, the remote desktop disconnects, the secure VPN collapses. In that world, a split-second drop-off is completely unacceptable. It ruins the illusion of the luxury experience, and it destroys the utility of the vessel as a mobile office.
Wow. So the system has to be essentially bulletproof. But how does the bonding actually prevent that split-second drop?
So what the MDS Blender does by bonding those connections isn't just giving you a backup that a router has to manually switch over to. It creates a seamless, load-bearing net.
Like they're all working together at the exact same time.
Yes. Data is sent in tiny packets. If the Starlink connection drops a single packet of data because of a wave pitch, the system instantly at the packet level fails over to the bonded 5G connection to deliver that specific piece of data.
Oh, wait, really? At the packet level?
Exactly. So the user on the video call never notices a blip. Their connection remains flawless. It's not a bicycle on the trunk. It's having a synchronized second engine that engages in a millisecond, so you never lose a single ounce of momentum.
That makes perfect sense. The failover is so fast, it's imperceptible to the human eye. But if you have up to 1 gigabit per second of data pouring into the vessel through this MDS blender, that massive stream of data needs somewhere to go, right?
Oh yeah, it has to be routed perfectly.
It requires a flawless internal network to distribute it. Which brings us to the next layer, the integrated nervous system. This is where the line between luxury entertainment and critical vessel safety gets totally blurred because they are both running on the exact same digital circulatory system.
This is where we see the transition from standalone gadgets to a true smart yacht ecosystem.
Let's look at audio-video, or AV systems. The Concord sources specifically mentions setups using JL Audio marine speakers and Crestron marine controls.
Top-to-line gear.
Yeah, and we aren't talking about running some speaker wire to a waterproof deck stereo anymore. These are fully networked, smart systems. They're managing multi-zone audio across different decks, controlling the ambient lighting, handling the 4K streaming, and it is all traveling over the vessel's internal Ethernet network.
But that exact same network backbone is also handling the vessel's monitoring and safety systems.
Right.
We aren't just talking about a loud analog alarm bell that rings when a pipe bursts in the bilge. These are highly sophisticated proactive network sensors.
What are they actually watching?
They're constantly watching the battery voltages, monitoring the bilge water levels in real time, checking the engine room temperatures, and reading the fuel and water tank levels.
So they're keeping an eye on literally everything.
Everything. The goal is to catch a microscopic anomaly in the data before it turns into a catastrophic physical disaster.
So what does this all mean? The irony here is just so thick. It means that if your vessel's network isn't architected perfectly, a guest sitting in the VIP cabin trying to stream a high-definition movie could, theoretically, hog the bandwidth and cause the captain's smart controls at the helm to lag.
It sounds crazy, but it's true.
You have entertainment data competing directly with safety data.
If we connect this to the bigger picture, that exact scenario is why Concord emphasizes that AV and internet infrastructure absolutely must be designed simultaneously.
You can't just slap a nice TV on the wall as an afterthought.
You really can't. You cannot treat the entertainment system as a separate luxury add-on anymore. It is pulling from the exact same data pool as the ship's safety sensors. To prevent the movie from crashing the helm, the system uses what we briefly mentioned earlier, programmable bandwidth allocation.
Okay, so how does that actually function in practice?
Well, the network router is programmed to physically prioritize the small, critical data packets coming from the engine room over the massive data packets coming from Netflix.
So easy.
Yeah, so if the network gets congested, it will throttle the movie stream to ensure the engine temperature warning gets through instantly.
That's incredibly smart.
It has to be. Furthermore, to make sure all these different brands of equipment can actually communicate, the industry relies on a standard called NMEA 2000.
Right, NMEA 2000. That popped up several times in the documentation.
Yes, NMEA 2000 is essentially the universal language, or the central nervous system standard of marine electronics. It allows a Garmin display to talk to a Yamaha outboard engine or a Fusion radio to talk to a Raymarine autopilot, regardless of the manufacturer.
Like a universal translator.
Exactly. It acts like an automotive CAN bus, ensuring that all this diverse hardware can share data reliably on a single backbone without crashing.
That level of integration is just crucial. I mean, for charter yachts and super yachts, this monitoring is about operational accountability.
Oh, completely.
If you are charging hundreds of thousands of dollars for a week-long charter, a missed warning about an overheating engine room doesn't just put the vessel in danger, it ruins the entire trip. Everything relies on the integrity of that internal network.
Which is exactly why designing this perfect, seamlessly integrated digital ecosystem on a whiteboard in an air-conditioned office is only half the battle.
Right, theory versus practice.
Making it survive the brutal physical reality of the ocean is another universe entirely. This is where professional installation makes or breaks everything we've talked about.
The sources paint a stark picture of this reality. These delicate routing systems, high-end touchscreens, and intricate NMEA 2000 networks have to survive constant corrosive salt exposure.
Which destroys everything it touches.
Exactly. And they deal with relentless pounding vibration from the massive diesel engines and the slamming of the waves. They bake in extreme heat inside enclosed helms, soak in high humidity, and they have to handle constantly changing power loads from the yacht's generators.
It really cannot be overstated how hostile the marine environment is to sensitive electronics. A sloppy installation leads to microscopic signal loss, power instability across the network, and incredibly expensive rework down the line.
Because it's so hard to fix once it's hidden away.
Right.
Yeah.
Professional installation isn't just plugging things in and turning them on. It requires comprehensive power and grounding reviews.
Actually, on that note, why is the grounding so critical on a boat compared to a house?
Well, in a saltwater environment, improper grounding leads to galvanic corrosion and stray electric currents.
Galvanic corrosion, what does that mean?
Basically, if your electronics aren't grounded perfectly, the electrical current will actually use the metal hull or underwater fittings of the boat to complete its circuit through the saltwater.
Wait, through the actual boat?
Yes. It will literally eat away at the boat's propellers and through hull fittings over time.
Oh, wow, that is terrifying.
It's a huge issue. And furthermore, professional installation involves highly precise radar calibration. If a radar dome on the mast is misaligned by even 1 degree during installation, that error magnifies over distance.
So a small mistake becomes a huge problem.
Exactly. At 5 miles out, the radar might show a ship in front of you when it's actually significantly off to the side.
It completely compromises the headlights of the vessel. And I want to highlight some real-world evidence of these installation challenges from the source material, because Concord has these 5-star reviews that tell you exactly what this looks like in practice.
Real-world horror stories, basically.
Pretty much. There is this one specific anecdote about a 68-foot Princess yacht. The owner had been dealing with stereo and networking issues since the day the boat was originally worked on by a different company.
Very common, unfortunately.
Right, so a Concord technician named Rich had to go in and essentially clean out what the reviewer called a dirty disaster underneath the helm. He had to hunt down bad connections, strip away poor wiring, and fix the fundamental NMEA 2000 backbone just to get things communicating properly.
It's forensic work at that point.
Yeah.
You're diagnosing invisible digital ghosts caused by physical world negligence.
That's a great way to put it, invisible digital ghosts. Another review mentions technicians having to run new networking wire from the pilot house all the way to the stern and into the captain's quarters on a 116-foot motor yacht.
Think about the physical logistics of that.
You can't just drill holes in the drywall like you would in a house, right?
No, not at all. It is like performing arthroscopic surgery on a luxury home. You have to snake these massive bundles of cables through a tight maze of hot machinery, watertight bulkheads, and pristine luxury finishing over a distance of 100 feet without damaging a single piece of custom woodwork.
And that leads to a critical distinction made in the sources. There's a massive difference between what the industry calls boat electronics and yacht electronics.
Oh, absolutely. It comes down to scale, complexity, and consequence. Yacht electronics require a significantly higher level of redundancy.
What's the practical difference, though?
Well, if a navigation system fails on a 30-foot weekend center console boat, you might have a frustrating afternoon and head back to the dock early.
Inconvenient, but you survive.
Right. But if a highly integrated system fails on a 150-foot super yacht carrying 20 guests and crew in the middle of the Mediterranean, you have a massive operational hazard. Yachts require deep automation and the ability to control and monitor systems from multiple helms or stations across the vessel.
So the stakes are just astronomically higher, which is why the expertise of the installer, specifically an NMEA-certified installer, is just as critical as the premium hardware itself.
It's the most important part.
You can buy the most expensive Furuno radar array and the top-tier MDS Blender, but if the grounding is wrong or the NMEA 2000 backbone is messy, you just bought yourself a very expensive headache.
Exactly.
The installer is the human bridge who translates the theoretical potential of the technology into the physical reality of a working vessel.
They are the ones ensuring that when the vessel pitches in that 10-foot swell we talked about earlier, the digital ecosystem doesn't blink.
So as we pull into port here and wrap up this deep dive, let's look at the big picture for you, the listener. What we've learned today is that a modern luxury yacht is not just a boat with some fancy iPads bolted onto the dashboard.
Far from it.
It is a carefully, meticulously architected digital ecosystem. It is a unique environment where the Garmin navigation displays, the Furuno radar sweeping the horizon, the MDS Blender pulling down satellite internet at a gigabit per second, the Crestron AV system playing music, and the hidden sensors monitoring the engine room are all talking to each other constantly, flawlessly, and in a shared language.
And they are doing it all while getting pounded by the immense physical force of the ocean.
And looking at this incredible feat of engineering raises an important question, something really worth chewing on.
Yeah, I think about this a lot, actually.
For centuries, the entire appeal of sailing out into the open water was the romance of leaving the world behind, right? The ocean was the ultimate escape from connectivity.
The great disconnect.
Exactly. But now we have the technology, the precise installation methods, and the satellite arrays to create an enterprise-grade, inescapable bubble of digital connectivity anywhere on the globe. You can have a flawlessly smooth video call while crossing the Atlantic in a storm.
It's a triumph of human ingenuity. We've essentially conquered the isolation of the sea.
We have. But does this hyperconnectivity fundamentally change what it means to get away from it all?
That's the real question.
Or does it simply redefine our relationship with the ocean? Maybe it's no longer the great unknown, the final frontier of solitude. Maybe, through the power of bonded networks and flawless integration, the ocean has just become another node in our global network.
It really makes you wonder if we're losing something while gaining all this capability.
It fundamentally challenges why we go to sea in the first place. We started by talking about how stepping onto a boat used to mean untethering yourself from society. Now it seems like the ultimate luxury isn't disconnecting from the world, it's having the power and the engineering to take the entire world with you seamlessly into the most hostile environment on Earth.
Thanks for joining us on this deep dive. Until next time, keep exploring.